Welcome back, guys. We just saw some things with this product rule, m through to a times m through to b. Anything that you have two radicals with the same index multiply, you can multiply the things underneath them, keeping the index the same. And we have the same kind of a rule for quotients, unsurprisingly, which says that if we have the nth root of some quotient, some fraction, basically we can write it as the nth root of the top or the nth root of the bottom. And we've done this before, again. We do it some with the quadratic formula, I think. But either way, what this means is I can write this as cube root of 27 over 8. I can write it as a cube root of 27 over the cube root of 8. Comme ça. Then I can take the cube roots individually. Sometimes it's easier to do it this way. That's the only reason this rule exists, really. Cube root of 27 is 3, cube root of 8 is 2, and now it's a nice happy 3 over 2. Right, so this, when I say this property, I mean the quotient rule. Like if I have, like I said before, if it goes this way, there's an equal sign, it goes this way as well. So if I have the nth root of some number over the nth root of some other number, I can write it as the nth root of the fraction, which again, is sometimes easier to find the answer to. So I can write this as the square root of the big fraction, 80 over 5. You're like, well, 80 over 5 is 16. That's true. Square root of 16, 4. So that makes this a little easier. If you had simplified this radical, you would have found that the square root of 80 is 4 root 5 over root 5. And root 5 cancel out, you just get 4. So like there's kind of two ways to do this one, but whatever. So this one is less obvious, maybe. I can write this as 5 times the cube root 32 over 2. 32 over 2 is 16. Now the question is, can you simplify the cube root of 16? The answer is a strong yes. 16 is 8 times 2. And 8 is a perfect cube. Cube root of 8 is 2. 5 times that 2 times the cube root of 2 is 10 times 10 cube roots of 2. Yeah. So maybe I'll just mention this. The reason I multiply the 5 and the 2, the cube root of 8 here, is because this is really, I would never write all these steps out. It's 5 times the cube root of 8 times the cube root of 2. What I just did from here to here is like exactly this rule. I had the cube root of something multiplied, and I did the cube root of the first times the cube root of the second. Right, I had the cube root of this times this, or it was the cube root of the first times the cube root of the second. So you see everything here is multiplied. 5 times this, and then you go straight to here. The cube root of 8 is 2, and everything's still multiplied, and then it's 5 times 2 is 10 cube roots of 2. So I think that might be a useful thing for you guys to keep in mind. So now there's these like really unfortunate, this is called rationalizing the denominator, which you guys have probably seen in Algebra 1. There's a rule, quote unquote rule, that says you shouldn't have a radical in the denominator of a fraction. This is kind of an antiquated rule that essentially existed when people did a lot of long division by hand. So like, I don't think it's that useful for you guys to learn it today, because no one does long division by hand anymore. But the reason I teach it at all is because when you guys take standardized tests, which you will take, the answers are almost always written as rationalized fractions. So I want you to know how to do it in case you see it on a test, basically. I know it sounds like a silly reason, but if they stop putting this silly thing on tests, I would stop teaching it, I promise. So unfortunately, this is the world we live in. So some of you may know that the way to get this radical out of the denominator of this fraction is to multiply both the top and bottom by that radical. That's just this operation here is called rationalizing the denominator. Rationalizing the denominator. And they call it that because when I get done, the denominator is a rational number. So root 3 times root 3, well, the top is root 21. Let's do that first. The bottom is the square root of 9. The square root of 9 is 3. Hey, no more radicals in my denominator. That was the whole point of doing this. I just explained why we do this, because people used to not have calculators, and they used to have to do long division by hand, and it was hard to divide root 3 into something, but those days are gone. But this is like a holdover from those ancient times. So we could do this the same way, but it's a little trickier. Let's just for a second, let's just be like, all right, well, up here we multiply, this is root 3, so we multiply by root 3. So let's maybe be like, but what if I just multiply by the cube root of 2? Same trick, right? I can't do the square root of 2 because there's cube roots, but I like up here I multiplied by the thing in the denominator and it works. So let's see if it works now. So the cube root, this would be the cube root of 10 on top, which is not a perfect cube, but I don't care because the top can be a radical. The bottom is now the cube root of 4, and that didn't work because 4 is not a perfect cube. Like what I want is I want this to be 2 cubed, right? It was just 2 to begin with. I want it to be 2 cubed, so the cube root of 2 cubed will cancel out and I'll just get 2. But in order to get 2 cubed, I have to multiply this 1 2 down here by 2 more 2's. I only multiplied it by 1. So really what I want to do is this. I split up my radical like I did in the first step here. I got to multiply. The trick is to get the thing inside here to be a perfect. The trick to get the thing inside of this radical down here to be a perfect cube. So I'm going to do 2 squared. That's really terrible. I'll write that again. Multiply the top and bottom by the cube root of 2 squared. Now there's 1 2 here and 2 2's here, which is going to make for a grand total of 3 2's in the radical, which is what I was hoping for. 2 times 2 squared is 2 cubed. You guys maybe know this number. This is 2 and that's 4 and that's 8. But I'm leaving it with the exponent to like demonstrate that I want this number and that number to match, basically. On the top, I will multiply that. 5 times 4 is 20. So it's the cube root of 20 over the cube root of 8. The cube root of 8 is 2. And that was the whole point of doing this. And now I'm done. Yeah. So maybe these problems, which are a little trickier, we'll do in class or something. I'll leave them on here if y'all want to try them and see if you can figure out how to do them. Have at it. This one in particular has a little. It's not impossibly hard, but there's like a little trick to it. So I'll leave that for you guys to do. These are the basics of rationalizing, and we'll do more in class.